for your eyes only. A secret mission. Your mission, should you choose to accept, is to learn about free radicals. Failure to complete this mission will result in the destruction of your grade. Operation commencing now. Free radicals have been spotted inside the human body. These nefarious compounds are believed to be associated with everything from aging to cancer. It is your mission to understand their structure and when they can exist. In order to do that, you have to understand what a free radical is. A free radical is a compound or any chemical species and now you know I can't spell. Shh. State secret. A free radical is a compound or chemical species or any chemical species with an unpaired electron. How can that happen? Well, they can and do exist. Perhaps the simplest example of them is nitrogen dioxide, often produced during coal combustion. Nitrogen has 5 valence electrons. You have 2 oxygens, each with 6 valence electrons. 12, that brings you 17 total. Right away, you should be able to tell that something odd is going on here. For the first time, we have an odd number of valence electrons. That means somebody's not going to get paired up. Who's going to be our central atom? Nitrogen. There's only one. It's surrounded entirely by oxygen atoms. Forming those bonds with nitrogen was costly. It cost us a total of 4 valence electrons, leaving us with only 13. To make the oxygens happy, we have to give in to their blackmail and give them 6 valence electrons each. 6 times 2 is 12. That costs us 12 of our 13 remaining valence electrons, leaving only 1 left over. According to our rules, all remaining valence electrons go on the central atom. Is that central atom of nitrogen now happy? It has 2, 4, 5. No, it wants 8. So what are we going to do? We're going to share a pair. And when we share that pair, we get a double bond. Now is nitrogen happy? It has 2, 4, 6, 7. No, it's not happy. Well, can we share another pair? What happens if we share another pair? When we share another pair, that gives our nitrogen now 2, 4, 6, 8, 9. Uh-oh, we have a problem. Nitrogen's in the second period. So it only has the S2 and it only has the 2s and the 2p for its valence shell. So it can only hold a maximum of 8 electrons. So it can't form that structure. So we're stuck. We're stuck with a Lewis structure where nitrogen has an unpaired electrons. As usual, we believe in social justice, and there's no reason to pick on one oxygen as opposed to the other. Meaning that, yes, not only do we have a free radical, but this free radical resonates.
What does resonate?
This compound has an unpaired electron, and there's nothing we can do about it. That makes this a free radicals. Now, free radicals don't like to exist. Sure, it's fun. They're young. They're in college. They want to be rebellious. So they'll be free radicals for a while, but they don't like that state. They want to pair up. This pairing up is very natural. Matter of fact, your free radicals are extremely reactive. That's one of the reasons they cause the cancer. That's one of the reasons they're a possible source of cancer in the body. For our nitrogen dioxide actually likes to form. Our nitrogen dioxide actually likes to dimerize. And dimerize is a fancy way of saying it likes to find another free radical and say, hey, I'm missing an electron, you're missing an electron, let's team up. Ah, the compound that loved me. All right, that's 2 James Bond references in 1 lecture on free radicals. And they wind up forming, not a double bond, that's what I draw. And they wind up forming a dimer. And I'm not going to draw the possible resonances of this dimer here. We're just going to roll with it. But that's so the free radical doesn't like to exist, so it actually forms another compound with itself. Halogens, remember all your halogens are diatomic in nature? Well, look at just a single halogen atom. A single halogen atom has 7, so they don't like that. So in nature, what do? They find another halogen, and they form a bond, which is why all your halogens in nature appear as diatomic, because if they were atomic, they'd be free radicals. So that's what a free radical is, and because they're so suspected in being a carcinogen, and because they were such a big health food fad in the late 80s, all the foods, you know, you're going to the GNC and stuff, and you're buying things to eliminate the free radicals from your body. That's the reason they're in your textbook now. Although they are a special case scenario, and a huge lot of the ones you will see in the body in particular will involve nitrogen. That's it. Beep.